So hello everyone, let us solve today's GfG problem of the day, and the problem name is find the number of islands. So let us read the problem statement first. So given a grid of size n cross m, where n is the number of rows and m is the number of columns in the grid, and grid consists of zeros and ones in it, and here zeros and ones are given in form of characters, not in form of integers, and here 0 represents water and 1 represents land. And the question is asking us to find the number of islands. Then they have given the definition of island. So an island is either surrounded by water or the boundary of the grid, and it is formed by connecting adjacent lengths horizontally, vertically or diagonally in all four directions. So an island is nothing but a piece of land which is connected by another land or a group of land which are surrounded by either water or the boundary of the grid. So this is what the question is saying. So let us see one example and try to understand what actually question is saying and try to find some solution out of it. So this is the example which I have taken. Now this is not given in the example test case. This I have taken by myself. So let us understand what the question is saying. So question is saying that 0 represents water in the grid and 1 represents land in the grid, and we need to find number of islands. Now what is island? Let us see. So they are saying that island is nothing but group of land which are connected together and which are surrounded by either water or the grid or the boundary of the grid. So let us see what is island in our grid. So we can see this there is one we find. This one is nothing but land. So we can see this one or this land is connected by another land. This land is connected by another land. This land is connected by another land. Similarly, this land is connected by another land, and this land is connected by another land. And this entire group of land is surrounded by water except on the top, which is the boundary of the grid. So we can say that this group of 1 is considered as one island or island. Yes. So this is one island which we have found till now. So this is what the question is saying about what is an island. So we can say this, yes, this is one island. Similarly, we can say that this is also an island because this land is alone surrounded by water on all of the side except for one, which is boundary of the grid. So we can say that yes, this is also another island. Similarly, we can say that this land is connected with this land is connected with this land is connected with this land, and you can see that it is surrounded by water on all of the side except for this one and this one, which is boundary of the grid. So this is another piece of island which we got. So let me just redraw this and make it more clear what are the island in this case. So these are the 3 islands that we found in our grid. So this was the part of what the question is asking us to find out. So we figured out what is island. We figured out by looking at the this grid how many islands are there. But the question is now, how do we find this solution? How do we find this 3? How do we find how many number of islands are there? So if you observe this carefully, what the question is asking us is, we can treat this island as one component. Can't we say that this is one component of land? Can't we say that this is one component of land? Can't we say that this is one component of land? Yes, we can say that. So we can say that we need to find components. Now what type of components? We need to find connected components, because you see these lands are connected to each other, then only we can say this is one island, or we can say this is one component. So indirectly the question is asking us to find out number of connected components. So this question is now become a question of graph in which we need to find the number of connected components. And this is simple. How do we find the number of connected components? Either by using DFS or BFS. So with this simple traversal technique, we can find the number of connected components, and this number of connected components is nothing but our number of islands that we want to find out. So I will now show you how with the help of DFS we will run our algorithm and how do we find this number of islands. So let us see how the algorithm will work. So let us see now how our algorithm will work. So in this case I'll be using DFS traversal technique, but you can also use BFS as well. So let us see how we can solve this question by simply using a DFS traversal. So what do we actually need to find out is group of ones together. So to find a group of ones together, first we need to find a single one, then only we can find its group by finding in all the 8 direction. That is what we have done in this case. First we figure out that yes, this is 1 1, then only we have searched in all the 4 direction whether it is 1 or not. So first we need to find a single one, then only we can figure out that yes, we have one connected component starting from this one. So what we can do, we'll be iterating on this grid with the help of I pointer for row and j pointer for the column, as we do in normally how do we traverse to the entire grid. So I will be going from 0 to n and j will be going from 0 to m. Now what we will do now, first we'll find out 1. So if grid of I comma j is equal to 1, as well as that particular land should not be visited, so we will maintain one visited set. Obviously we don't want to count this island again and again, that will run into an infinite loop. So we need to find one which is not been visited till now. That is obvious. So we need to find one particular one. So we need to find this particular one which is not visited till now. So what we can do, if grid of I comma j is equal to 1 and not visited till now, so what we can say, not visited of I comma j. So what we will do in this case, we will simply call a DFS starting from this I comma j with our visited and grid as parameters. And after this DFS is complete, so first let me show you how this DFS will run. So in this question we have been told that we can go in all the 8 directions. So we can go upward, we can go downward, we can go right, we can go left, we can go to diagonals as well. Now how do we represent these all direction in form of I comma j? So let us say that we are traversing with the help of I comma j. So this one is represented as I minus 1 comma j. This one is represented as I minus 1 comma j plus 1. This one is represented as I comma j plus 1. This one is represented as I plus 1 comma j plus 1. This one is represented as I plus 1 comma j. This one is represented as I plus 1 comma j minus 1. Similarly, this one is represented as I comma j minus 1, and this one is represented as I minus 1 comma j minus 1. So these are all the 4 directions in which we need to search for our land to get one connected component. So let us see how will we find out with this particular one. So we are currently standing at this one when this condition will hit. So we will check in its upward direction. So it is boundary, so we don't want to do anything. We will go here. So it is water, so we don't want to get water, we only want to get pieces of land. So we need to find only ones which are not visited till now, otherwise it will go into infinite loop. So we will search here. So yes, we found one here. Then again with this same case here, we will run a DFS for this one to find some another connected land. So we will search here. So no, this is the boundary. We'll again go to backwards, but we will figure out this one is already visited. So with the help of this we will find this one. Similarly, with the help of DFS call we will again find this one, then we will find this one, and we will find this one. So no other one will be found other than these 6 ones, because either there is some boundary or there is some group of water which are together. So this is one island that we find out. So what do you observe? This DFS will stop at some time. So whenever this DFS will stop, will again come out of this DFS. So what this DFS is telling us? This DFS is telling us with this particular one, I have surely find out one connected component or one group of or one island. So we can increment our answer here. So we will initialize one answer variable which will keep track of number of islands which we have till now. So we will increment our number of islands, because just imagine if we find out one particular one which is not visited, so it doesn't matter if it has connected lands with it or not, because that single one is in itself a one particular island. So if we hit this condition, so after this DFS will get over, then surely we can say that we will get one island for sure. Similarly, when this traversal will get over, so this for loop will continue to run, and then what is the next one that we will come across? So let me just clear it out. So when this DFS condition will get over, our for loop will continue to run and it will look for some other one which is not visited till now. So it will find this one, and again DFS call will start from here and it will try to find some connected component to it, or the connected land to it in all the 8 direction. So it will look for it in all the 8 direction, but in this case it will not get anyone. So this single one or this single land is in itself will be considered as one island. So our answer or the number of island till now will become 2. One is this one and the other one is this single one. So if you observe carefully what this DFS is doing, it is letting us know a particular connected component. So in this case we started our DFS from here. So whenever we find a single one which is not visited, so with the help of DFS we are able to find a connected component with this one, and that connected component is nothing but our island. So this is how this algorithm is working. So again for this, after the DFS will get over, this for loop will continue to run. So we will come across this one. So again this DFS call will occur and it will try to find connected component with this one. So it will go here, it will find one, it will again go down there and it will find one, again it will go to bottom and find one. So with this one we will find another connected component which is nothing but another piece of island. So our answer will now become 3. And after that you will not find anyone in this particular grid which is not visited. You can say these all ones are visited, this single one is visited and this group of one is also visited. So these for loop will get over and in the end we will return this answer. So this is how our algorithm will be working, and how this DFS function will work I'll not explain that, this is pretty basic. So hope you understood this part, and let us just write the code now. So let us write the code now. So first we will declare a number of rows and number of column. So n is number of rows, so it will be nothing but grid dot size. M will be the number of column, which will be nothing but grid of 0 dot size. Now what we will do, so let me correct this. Yes, so first what we need to do, we need to make one visited vector or visited matrix, whatever you say, which will be of same size as of our matrix. So n comma m, which will be initialized to 0. So what does that mean? So initially nothing is visited. Now what we need to do, we need to run for loop for our entire matrix to find one particular one which is not visited till now. So for that we will write something like this. So there is one mistake of typing, so let me just correct that. Yes. So whenever we find one, so whenever grid of I comma j is equal to 1, so this one is a character. You can see that. So this one is a character, not integer. So that's why I am writing like this. So whenever we find one that is not visited, so that is how we'll write this. So whenever we find one that is not visited, we will simply call it DFS. And in that DFS, we will pass grid, we will pass our visited matrix, we will pass I comma j, as well as we will pass n comma m to check for the boundary condition. And when this DFS will get over, what this DFS will find out? This DFS will find out one connected component. And whenever we find one connected component, we will just increment our answer. And that connected component is nothing but the island that we found. So we need to initialize one variable answer which will be initially 0. Now the only task remaining is to write the DFS function. So let us write now. So our DFS function will be void. So yes, our DFS function will be void, and we will take vector of character for our grid and vector of int for our visited. So again I have one typing mistake, so sorry for that. So let me see if I have written correctly. Yes, visited, and integer I will be as it is, integer j, integer n, and integer m. So what will be the base condition? The base condition is simple. If we have already visited one particular land, or if there is some water, or if there is boundary of the grid, we just need to return. We don't need to go ahead to call our DFS. So we will write that. So if grid of I comma j is equal to 0, or visited of I comma j is equal to 1, that means this particular land is already visited, or this particular I comma j is already visited. So in that case we need to return, but before that we need to check for the boundary condition as well. So if our I is greater than equal to n, or our j is greater than equal to m, or our I is less than 0, or our j is less than 0. So in all these cases we just need to return, because there is no point in calling the DFS. If we hit this boundary condition and if we call DFS, we will get error, and we don't want to include water in our connected component, so there is no point in calling DFS for water. And this is obvious. If we have already visited one land, we don't need to go to that land again, otherwise it will just keep on going into infinite loop. So we are just returning from here. Now otherwise what we will do? So if this condition is not hit, so what does that signify? That signify we are currently standing on grid which is value 1 and which is not visited till now. So first we need to mark that particular I comma j to be visited. Then from that particular land, we need to search in all the 8 directions and find out the connected lands to it. So we need to call 8 DFS function in all the 8 directions. So let me just write that out. So it will be grid comma visited comma I comma j comma n. So I'll just copy paste it 7 more times, and then I can just change the I comma j value. So first direction will be I plus 1 comma j, second direction will be I minus 1 comma j, third direction will be I comma j plus 1, then I comma j minus 1. For diagonals we have I plus 1 comma j plus 1, we will have I minus 1 comma j minus 1, we will have I plus 1 comma j minus 1, we will have I minus 1 and j plus 1. So these are all the 8 directions in which we need to search for one land. And after this all thing is performed, we will find one connected component with this when this DFS call will get over, and then we are incrementing our answer to find for finding one particular island or connected component. So this will keep on happening until we figure out all the ones that are not visited in our matrix, and in the end, after figuring out each and every connected component, we just need to return our answer. So this is how our code will work. So let us see if this gets submitted or not. So yeah, our code got accepted successfully. So hope you learned from this video. Thank you.